Well, hello all. My name is Stephen Thomas, and today I'm starting a section on electricity. One of my favorites. I love electricity. I'm sure you do too. What powers your cell phones? What powers the world if it's not electricity? Okay, so if we're going to study electricity, I've got a little battery box and it's got little terminals on the end. So I'm going to stick my battery box there. And the question I've got for today is, does water conduct electricity? So I've got my electricity, I've got water, and you know what I'm going to do? I'm going to stick the ends of the probes into the water and we're going to see whether it conducts electricity. So, can you see anything? No. Why not? Because we cannot see electricity. That's the problem. So to help us see electricity, I've got one of these lovely little things. They're called an LED. I just love these little guys. They come, one with a stumpy leg. You'll see if you put the legs together, one is shorter than the other. The shorter one must go to the negative, and the longer one goes to the positive. So let's take our battery box, and I'm going to attach to the black wire the shorter leg, and I'm just going to wrap it around this leg. And we're going to put that into the water, the red and the longer leg of the LED. And what do we notice about the LED? Do you see that it begins to glow? Now, this is water just straight out of the tap. So here we can see that a simple circuit which just consists of an LED, and just the water closes the circuit. So obviously a current must be flowing between this red lead and the other terminal of our LED. So we can see that water does conduct an electric current. Another way that I could do it is as follows. I could take my multimeter. Here's my multimeter. And I can turn it on to this here is measuring in ohms. Now let's see, resistance of anything, including the resistance of the water, is measured in ohms. So let's measure 700, you see how it changes, 800, 900, and that is in thousands, 900,000 ohms. Now, I've got an even more exciting way of telling what resistance is. And that is this little setup here. What it's got is a little speaker on top. It's got a little 555 chip there, and it's supplied with electricity. Now the 555 vibrates at a certain frequency depending on the resistance of whatever is placed across these two wires here. So there's the two wires. So here is my box, and I'm going to place these two wires into the water. Can you hear that? We can actually tell the resistance that this is conducting, first of all, because when I pull it out of the water and we've got air between the two wires, we hear nothing. And then when I put it into the water, the higher the frequency. Let's see what actually happens if we add some salt. How about that? That's interesting. Should we throw some more salt in? Listen to the high frequency of that sound. Okay, I think that's about enough of that. That's about as much as we can bear. But why don't we go back to our... Let's go back to our multimeter. Look at that. You see how that number is lower now? Look at that. It used to be around 800. Now it's half of that. Definitely by adding salt to the water, we have decreased the resistance by almost half. Let's go back to our original circuit, which was this one. And let's see if our LED glows any brighter. Here is a closer up look at the water conducting electricity. You've got to get right on top of the LED or you can't see that it's glowing. This is just pure tap water without any salt in it. You see how you can only see it from directly above. Now, while we're looking at that, I'm going to just try and pour some salt water into here. And let's just stir it. Now just look at how bright that is. That is the water. You can even see it from the side how well that LED is glowing, but look from the top. Wow, that's bright with salt in it. So there's the conclusion of our experiment, that when we add salt to water, the water has a lower resistance and conducts the electricity better.